In this problem, we're going to look at several numbers and determine the number of significant digits in each number. So let's look at whole numbers first. So the first number we're looking at part A is 248,735. So that's 248,735. Now in a number like this, the first thing that you have to look for is the zeros at the end. So since there are no zeros, every digit counts. So we have 1, 2, 3, 4, 5, 6. So the number of significant digits is 6. Let's look at part B. 248,740. Now, in a whole number, the last zero does not count. So if you're looking at zeros at the end, the zeros at the end of whole numbers do not count as significant digits when we do the counting of significant digits. So let's see how many we have. That's 1, 2, 3, 4, 5. We stop here because the last digit is a 0 and it doesn't count in this case. So we have 1, 2, 3, 4, 5 significant digits. Now let's look at the next number. It's been rounded to 4 or at least the hundredths place. Look at the zeros at the end. The zeros at the end of a whole number do not count. Okay, so let's count the number of significant digits. It's 1, 2, 3, 4. There are only 4 significant digits in this part C. Let's look at part D. Now you get the idea. The last three zeros do not count. So we're counting the number of significant digits. If we have zeros at the end of a whole number, those do not count. So we have 1, 2, 3 significant digits. So I think you get the idea by now. In a whole number, when we are counting the number of significant digits, if the whole number ends with zeros, do not count those zeros. Now let's look at decimal number examples. Our first decimal number is 24.387. Now in this case, in the absence of zeros, either in the decimal place values or in the whole numbers, you got to remember that you have to look for those zeros. When it's a decimal number, all you care about is you're looking for the zeros at the end. So here, every single digit counts. So that's 1, 2, 3, 4, 5. So the total number of significant digits is 5. Next, let's look at 125.390. Remember that this is not a whole number. So the 0 at the end here is a completely different situation. Since it's not a whole number, if there is a 0 at the end and it's in a decimal place value, then every digit counts. So we have 1, 2, 3, 4, 5, 6. Notice that even the last 0 counts because it's in a decimal place value. So the total number of significant digits is 6. Same thing again. I'm just looking at a similar example just so you remember how to do this. Remember that there is a decimal point. If it's a whole number, it's a whole different story. If it's a whole number, then the zeros at the end do not count. But if it is a decimal number, the zeros at the end do count if it's in the decimal place value. So we go again 1, 2, 3, 4, 5, 6. Do you see that nothing changes? Every digit, whether it's in the decimal place value or in the whole number values, count. So all 6 count. Again, just to make sure you understand, I have another similar example. Notice that nothing is changing. The number of significant digits continues to be 6. It's 125.000. Now, if this were a whole number, then we wouldn't count the last 3 zeros. However, this is a decimal number, so the zeros at the end do count. They are significant. So 1, 2, 3, 4, 5, 6. So again, it remains 6. Now let's look at a few examples. We have 10,000.2. Notice that there is a whole number and then a decimal point and then the decimal value of the number. The minute it's a decimal number, you only look at the decimal place values to determine the number of significant digits. Notice that's a 2, so that does count and everything before that counts. So we have 1, 2, 3, 4, 5, 6. So there are 6 significant digits in this number. Let's look at this one. Again, notice that it's a decimal number. Okay, if it's a decimal number, you have to look at the decimal place values. Even if it's a 0, the zeros are there for a reason, that those zeros tell us that the number has been rounded to the hundredths place. So the 2 zeros after the decimal point are significant, and hence everything before that is significant. So we have 1, 2, 3, 4, 5, 6, 7 significant digits. Now let's look at this number, 10,000. Notice that there is no decimal portion of the number, it's a whole number. And in a whole number, the zeros at the end do not count. So there's only one value that counts, and that's a 1. So that's another example. So the number of significant digits is 1. Now what if we had, this is one last example, 1, 0, 0, 0, 0, 0, 1. Notice that there are a bunch of zeros in the middle, but the last digit in the whole number is non-zero. So every single digit counts. 1, 2, 3, 4, 5, 6, 7. So there are 7 significant digits in this number.